A circle fits perfectly inside a square. Now another smaller circle is placed in one corner. It touches the two sides of the square and also just kisses the large circle. Here is the puzzle. If the large circle has radius capital R, can you find the radius of the smaller circle? Let's see. Since the smaller circle touches the left and bottom sides, its center must be exactly small r units away from each side. Likewise, because the large circle is inscribed in the square, its center is exactly capital R units away from each side. Now look at the two centers. Horizontally, they differ by r minus r. Vertically, they also differ by r minus r. Draw these two segments. They form the legs of a right triangle. Now connect the two centers. What is the length of this line? Because the circles touch externally, the distance between their centers is simply r plus r. Everything we need is now in one triangle. This is my favorite kind of geometry problem. At first, it looks like there isn't enough information. But once you see the right triangle inside the picture, the puzzle almost solves itself. The trick is never complicated algebra. It is seeing the right shape. Now apply the Pythagorean theorem. We obtain r plus r square equals r minus r square plus r minus r square. Since both legs are equal, we get r plus r square equals 2 times r minus r square. Expand both sides. R square plus 2 times r plus r square equals 2 times r square minus 4 times r plus 2 times r square. Move everything to one side. We get r square minus 6 times r plus r square equals 0. Instead of solving directly, divide everything by r square. Let x equals r by r. The equation then becomes x square minus 6x plus 1 equals 0. Applying the quadratic formula, we get x is equal to 3 plus or minus 2 root 2. One solution, 3 plus 2 root 2 is larger than 1, which would make the smaller circle larger than the big one. So the only valid solution is x equals 3 minus 2 root 2. Substituting back, we get small r equals 3 minus 2 root 2 times r. Notice something beautiful. Since root 2 minus 1 the whole square is 3 minus 2 root 2, the answer can also be written as small r equals root 2 minus 1 the whole square times capital R. The best part about this problem is that it didn't need any advanced geometry. Just one right triangle and the Pythagorean theorem were enough. That is the beauty of mathematics. Finding the right idea is often far more important than doing long calculations. If you enjoyed this video and want to learn more, subscribe. I'll see you in the next one.